Hello everyone, and welcome back to my channel. This is Vishnu Anjipudi, and today we will be solving problem number 22 of the 2017 AMC 8. The problem reads, in the right triangle ABC, AC is equal to 12, BC is equal to 5, and angle C, which is right here, is the right angle. The semicircle is inscribed in the triangle, as shown. What is the radius of the semicircle? Now, there's two main ways that you can approach this problem, and I'll be covering both. The first method is to use similar triangles and the fact that tangents are perpendicular to radii. If we draw the center of the semicircle, which is right here, and label it O, what do we have? Well, we can draw the point O to this tangent line at, say, point D. Now, since these two lines are tangent, you can draw a right angle. And since angle A is in this bigger right triangle DOA is 5, 12, 13, just like triangle ABC. And now the convenient thing about this setup is that we can actually find the length of AD rather easily, since both BD and BC are tangents to semicircle O coming from the same point. By the equal tangents principle, we have that BD is equal to BC. In other words, this is just 5. Thus, since the entire length by the Pythagorean theorem, since we know AB is equal to 13, or by Pythagorean triple, of course, you know that AD is going to equal to 8. And now, since we know that the 8 in triangle ADO corresponds with the 12 in triangle the 12 in triangle AC, since because of the smaller angle corresponding to DO and BC, we know that the radius of this semicircle, DO, is equal to 5/12 of DA. And this is, of course, going to be 5/12 times 8, or 10/3, which is choice D. Now, let's go over the second way of solving this. And this second way is also pretty slick. So, you have triangle ABC. And this time I'll just draw it vertically, and you'll see why in a second. So you have this triangle right here. So you know that this is a right angle, this is A, this is C, and this is B, and this is the desired semicircle. We can actually reflect this right triangle over the line AC, like this. So the dotted lines are the reflected portion. And this drawing is not that good, but immediately you can see that the desired semicircle becomes a circle. It is in fact the incircle of triangle ABB prime, if you label the reflection of B as such. So you know that the in radius times the semiperimeter is equal to the area. And now this is what we're going to be using to find the in radius in this case. So in radius is equal to the area. So since we know that the in radius times the semi-perimeter is equal to the area, why don't we just find the area and the semi-perimeter? Now the area is simple. The area of AB prime is simply AC times BB prime over 2, or just AC times BC, which is 5 times 12, or 60. Now we look at the semi-perimeter. So here we note that the semi-perimeter is going to be AB plus AB prime plus BB prime. Now, straight off the bat, we know that AB and AB prime are equal to 13. Additionally, we also know that BB prime is equal to BC times 2, which is equal to 10. Thus, the semi-perimeter is 13 plus 13, so S is equal to 13, plus 10 all over 2, which is equal to 18. Thus, if we just bring everything up here, we have that R times the semi-perimeter, which is 18, is going to be equal to the area, which is 60. Solving, we see that R is indeed equal to 10 over 3, verifying our final answer, choice D. And we are done. Thank you so much for watching this video. It really means a lot. Please don't forget to like, share, and subscribe, as well as click the bell icon. As always, if you have any questions, comments, or concerns, please post them down below or email me at steamaspirations@gmail.com. This is Vishnu Ajipudu, signing off. Bye.